This immediately, again, I'm thinking there's probably a ring here. There's tons of degrees of unsaturation here. If it's fully saturated, it'd be C9. 9 times 2 is 18 plus 2. So remember, this is 2n plus 2. Double check my, or take a look at my unsaturation videos if you need to know how to figure that out, how to calculate this. But the degree of unsaturation would be the difference between these two, 20 minus 10, and divide that by 2. So it looks like 5. There's 5 degrees of unsaturation. If we have a ring here, like I suspect, here, this would give, remember there's 3 double bonds in here. Rings and double bonds each give 1 degree of unsaturation. So this has right now 1, 2, 3, 4. So there's actually 1 more degree of unsaturation, which will either be, again, another ring or a double bond. Okay? So who knows, this is either attached at 1 or 2 places. But this is C6. That means if this is C6, maybe H5 or 4, we're not sure, H question mark, then this is C3. This could be like 5 or it could be 4. So this is C3H of 5 or it could be 6 to add up to a total of C9H10. So it looks like we got some of that. If you're thinking, okay, maybe it's 2 CH3s, like this, that's interesting, but it wouldn't give the full 5 degrees of unsaturation, and we wouldn't add up to C9H10 without it. Or I think, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the carbons, though, would be 1, 2, 3, 4, 5, 6, 7, 8. We'd be missing a carbon if we did it that way. So this is not like 2 CH3s or something like that. That wouldn't be possible. So we've got to work on that a little bit. Let's take a look over here. These hydrogens are next to 2 other hydrogens. So we know because of this, there has to be a CH2 somewhere. Because these are next to 2 other hydrogens. I guess there could be 2 CHs, though, because, however, since we have so few carbons left, it doesn't seem like 2 CHs is possible. So there's some amount of carbons here that are next to 2. And then here, it looks like there's some hydrogens next to a bunch of others. Hydrogens. I don't know how many. It could be like 4 or 5, whatever. Well, if I use up another carbon, then I know there's 2 more left, because there's a total of 3 that I'm working with here on the right-hand side. This is probably the one next to the ring, and then these are the ones further from the ring, just because these are more shifted to the left. Okay, since I don't know if I'm going to be able to get another double bond, but maybe I can get a ring. So if I have something like H2, CH2, and then let's see, what would this be? CH2 also. We could take a look at that. That would add a ring. And the nice thing is I'm adding 3 more carbons, which is how many I have left. And I'm adding 1, 2, 3, 4, 5, 6 hydrogens. There's 1, 2, 3, 4 more there. So that'd be a total of 10. Everything looks good so far. Let's take a look at the shifts. So this would give that singlet, these hydrogens here. These 2 hydrogens are equivalent. And so these 2 sets of hydrogens are equivalent. And they would give a triplet because they're next to 2. So that's probably those right there. These are right there. They're giving a triplet because they're next to 2. These here, they're their own kind, and they're next to 1, 2, 3, 4, so they could give a quintet or 5 peaks. That's probably that one right there. This structure here works. That's our final structure.